Hey everybody, Braden here from MicroFusion Motherboard Repairs. Today we're going to be diving into a question I've seen been asked a lot. When is it okay to remove a capacitor from a circuit? Spoiler alert, sometimes removing one is okay if you understand the math, the engineering, and tolerances involved. Let me explain. First, let's talk basics. When capacitors are connected in parallel, the values simply add up. So, if you have two 10 microfarad capacitors in parallel connected circuitry, their value adds up to 20 microfarads. Now, let's look at an application where this principle is used. So, here we are now over on ZXW, our board viewing software. We are looking at an iPhone 12, okay, just a standard iPhone 12, and this is the board view of it. Okay, highlighted is VDD main. This is a very common power rail. Okay, it's made for supplying pretty much every circuit. Main chip on the board takes VDD main. See, on every chip. Okay, so this is a power rail that is a high load, needs a lot of smoothing and whatnot. So in turn, you find a lot of capacitors on the circuit. So you can see here, this is all our parallel connected capacitors. This is VDD main, and the grey is ground. So in turn, they are all parallel connected, meaning that they all add together. So as you can see, all connected in parallel. If I click on one here, it will take me over to the schematic. Okay, so then this is it. This is that chip, and this is the capacitors in question over here, okay? Main power rail here, the ground connection here, all in parallel connection, okay? Now there is a number of capacitors for VDD main. You just don't see them. You just see the ones sort of closest to the chip that are mostly relevant for it, but they are all working together in conjunction to deliver smooth, consistent power. So you'll see, I'll go over to this chip, and you'll see it'll take us to a different chip in Fish, the viewing software, and you can see, okay, up here, VDD main again, goes over to more parallel capacitors, okay? So what I have done is I've gone ahead and I've counted up all of these. As you can see, there's 26, 15 microfarad capacitors all connected in parallel on this side of the motherboard in question. Okay, there's more throughout the whole board, but we'll just look at these couple. 15 microfarad, 26 total. Yeah. Okay, let's have a look at that. Okay, we have our 26 15 microfarad capacitors connected in parallel. So that's 15 plus 15 ... dots mean recurring. To shorten that up, I'll do 26 times 15. That equals 390 microfarads total. I have just realized I should have written 25 times 15 microfarads equals 375 microfarads. I do have 26 times 14, disregard that. Now, we put the small over the big times 100, so 375 over 390 times 100 equals 96.15% remaining. That's rounded to a 4% efficiency loss. 4%. Is that a big number? Is that a small number? Well, if we look into the manufactured tolerances, we will see the answer to this question. Okay, for the next part, you will find that with every capacitor that you purchase, whether it be for whatever sort of circuitry, residential, electronics, whatnot, all the capacitors you purchase come with a percentage rating written on them. This percentage represents the high and low percentage rating that capacitor can be for the value that it is designed for. So in our case, our 15 microfarad capacitors actually show us on ZXW that they have a 20% rating, okay? So that's plus or minus 20%, meaning the lowest can be 12 microfarads and the highest can be 18 microfarads. So in the factory, when they're coming off the line, they'll measure it. If it's in between these ratings, boom, that hits the mark for a 15 microfarad capacitor at 20 plus or minus. Now that could be quite a bit. You'd be right to think so. So let's have a look at our total numbers. We take our 390 microfarads from earlier, and that means that it can have a lowest rating of 312 microfarads. If every capacitor happened to be on the lowest side, that's where it will end up at max to meet. and therefore the highest can also be 468 microfarads given the same circumstances. That equals 156 unit difference, plus and minus, meaning that if we now go back to that 4% loss of efficiency from the previous slide, that the answer is purely, it is negligible. The total loss of one capacitor being moved or removed from a main power circuit, it doesn't matter. But if you are doing a repair for someone based on the context of that situation alone, you should repair your devices to the standard that they bought it at. It's just a simple right of service, but for data, for these simple cases where we're just trying to hunt down and figure it out, removing one capacitor really makes no difference. If you feel inclined to remove one of your own accordance for your own device or whatever, you can sleep easy that this is the case. So furthermore, my final point, this isn't a secret. The engineers who designed the circuits, people who have studied this for years, are fully aware of these circumstances, and they go even further. So they know how many capacitors they need. They'll add a couple for that little bit extra smoothing, that if all the capacitors happen to swing low, that is compensated. If it happens to, all add up, is covered. So from every angle, one capacitor is okay to remove. So yes, in some cases, especially in parallel connections with redundancies and tolerances taken into account, removing a capacitor is totally fine. But always do your homework. If you found this helpful, give it a like, share it with a fellow tech, and follow MicroFusion Repairs for more deep dives like this. See you in the next one, guys. Cheers.